So this is a little movie on how to use the ArcJet panel in the ADSI tool. So the first thing you'll notice is there's a couple of these data files, and these have the ArcJet databases. So you won't have to actually worry about these, except they should be in the same place as the executable. So if you look at them, it's just basically columns of data. It's got the arc current and the mass flow, the bulk enthalpy, and the stagnation point heating, and the wall pressure. So to launch ADSI, the easiest way to do it is just to double click on the ADSI executable icon. You click that, comes up on your screen. We're going to pull it down so you guys can see it. So to run the ArcJet application, you go up to the top and you click on the ArcJet tab. And then you pull up this is the ArcJet screen. And there's a number of inputs here. The ones on the left here are the ones where you specify which database is going to be used. And you pick the ArcJet itself. In this case, there's only going to be the AHF. You pick the nozzle. In this case, currently there's only the 18-inch. You can pick the model. In this case, there are actually a number of options, the hemisphere, sphere cone, or the blunt cone. We're going to stick with the hemisphere. Model standoff, currently also right now there's only one. This window right here is going to tell you which is your current database. In this case, we have the hemisphere. If we switch it to the sphere cone, say, it's now going to say the sphere cone. This window in the right is going to show you what your database looks like. And so you can pick the things that will be shown on the X and the Y axes. In this case, it's going to show heating rate and pressure. You can change it if you want. We can show current and mass flow rate if you want. You can change the range here if you care to. You can change the number of ticks and things like that. So this is just to give you an idea for the range and extent of your database. So up here, you get to pick the method that will be used to interpolate, and whether it's a 1D, 2D, or 3D. Generally, for the ArcJets, it's going to be 2D, and the default method is this one here, KD tree. So you probably won't have to actually worry about these at all. So to run the code, you pick some target point in your database. And you can pick any combination of the things which are in the database. And as I said, it's heating rate and the wall pressure, the arc current, the bulk enthalpy, and the m dot. So let's start doing the current and the m dot as the variables that will be interpolated. Now you've got a little target point here. If you want to look at it on your screen, you click this little box here, and your blue dot shows where that is. So to run the code, you pick your target point. You can change this, of course. So let's change it to, say, 81 for the mass flow rate, and let's change the current. Let's see, 81's up here. I want to go outside of the database at first. Let's do it 1500 amps for the current. Then if you want to update the location of your target point, you hit redraw plot. It's going to update it here. And so right now we see that the target point is actually not inside of our database. And then when you want to interpolate, you hit the compute button. And it's going to warn you that in this case your target point is actually outside the database. It is going to run though anyway. And so what it does, it is going to interpolate all of the other variables to your target point, and the results are going to be listed here. So we were doing from current and mass flow rate, it was 1500 to 81. It's going to show those two down here as being unchanged, And then it's going to show you the heating rate, pressure, and the bulk enthalpy based on that target point value. And now if we switch the target point so it's actually inside of our database, you can do that by just changing the target point. You can update the plot to see where your target point is now. You hit the compute button again, and now it is not going to give you that message that it's outside, because it's not outside, and your results are here. And like I said, you can pick any combination of these. So in this case, we're picking the current and the mass flow rate, and we're getting heating rate and the pressure. But you can also go backwards from that. So you can specify a heating rate and a wall pressure, and it will interpolate what the current and the mass flow rate is to get that value. So let's try that. So let's pick something that's inside of our database. Let's go a heating rate of 180. And let's go a pressure of, say, 3 kilopascals. Now if we hit the compute button, I could have updated our target point as well. It's right there. And now if we hit the compute button, it's going to keep the heating rate and the wall pressure constant, and it's going to interpolate the current and the bulk enthalpy and the mass flow rate with which to get it. Now if you want to keep this data, you can actually write it out, and if you want to do that, you click the write button, and it will pull this up. You pick the name of your file, test out texts. You can save it, and then it's going to write that out as a text file. And if you want to take a look at that, you can just open it up in any application that you want, and you can keep the output from your run. And that's pretty much it. There are some other more complicated things which I will not cover in this video here. So that's it, pretty much. Thank you.